Hi. So today we are going to discuss this daily problem named minimum distance between three equal elements. So what does the question says? You are given an integer array length. A tuple ij give of three distinct indices is good if all of the elements at that three indices are equal. The distance of a good tuple is defined as the absolute sum of the differences between every pair of indexes, where absolute defines the absolute value of x. So this is the distance of a good tuple. What we need to return is the minimum possible distance of a good tuple if no such good tuple exists minus 1. So I think let's take this particular example. So if you look at this particular array, so let's label this as 0, 1. Let's label this index as 0, 1, 2, 3, 4, 5, 6. So what defines a good tuple? So a good tuple it will be any three elements whose value are equal. So I think this is a good tuple where one is occurring three times. All of the values in these three are equal and they have indexes at 0, 1, and 5. So this is a good tuple. So this is a good tuple because all of the elements at these indices are equal. And what is the distance of this? So distance will be the difference of this, the difference of this, and the absolute difference of this in the sum. So it becomes 1. So it becomes 1 minus 0 plus 5 minus 1 plus 5 minus 0. So what it becomes? It becomes 1 plus 4 plus 5. It becomes 10. So the distance of this group tuple is 10. Now, this is for one such case. There we can also see that there is the number 2, which also occurs 3 times. So if we look for the group tuple of 2, 2 occurs at index 2, 4, and 6. So the distance for this will be 4 minus 2, which is 2, plus 6 minus 4, which is also 2, plus 6 minus 2, which is 4, and the minimum distance comes out to 8. So in this case, we will take the minimum of these two, which is 8. Hence, 8 is the answer. We didn't saw any other such element occurring 3 or more times. So in that case, our answer is 8. So let's see. Let's first look at what are the possible uh, cases when it can't occur. So we need at least three numbers in the array. So if we look at the size of this array can be up to 10 raised to the power 5, with minimum being 1. And each element in the array will always be less than equal to the size of the array. So we see that if n, this case 1, uh, so yeah, so if n is less than equal to 2, it means if there are only one element in the array or there are only two elements in the array, then we can never form a tuple because the tuple needs three elements. So in that case, answer will always be minus 1. So it is never possible. So this is our first case. So uh, how can we approach this? Okay. So let's assume case 2. uh, we have an array like this only. We take this particular array itself. So 1, 1, 2, 3, 2, 1, 2. Now there can be 2 as well. 1, 3, 1, 1. Okay. So let's say this is our array. This is a nums array. Uh, 3 and 3. Yeah. So what can we do is that we can try to find all the indices of a particular number. So let's say if we label them, it becomes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So these are the indexes of these elements. So we can try to group all the indexes that are for a particular element. So if we take 1 in, so the number 1 occurs at which of index? It occurs at index 0, 1, 5, 9, 11, and 12. So 1 occurs at these 6 indexes 1, 2, 3, 4, 5, 6. Similarly, we can group 2. 2 occurs at index 2, it occurs at index 4, it occurs at index 6, 7, 8, 6, 7, 8, 2, no, okay, these are. And the number 3 occurs at index 3, it occurs at index 10, it occurs at 13, and let's say 14. And let's say we have one more element, let's say 5. So, and 5 occurs at only one index, that's 50. So, what we did was that we first, because we needed this particular condition, that to form a tuple, all of the elements should be equal. So, if we see that if I pick any three, if I pick any three numbers, any three indexes, it is sure that they are all one because we can group according to the numbers value. So if we pick any three indexes, all of them would be one. Pick any three from this, they would be a good tuple. If I pick three from this, it would be a good tuple. I pick any three index, it would be a good tuple. But I can't pick from this group because it needs at least three indexes where pi is correct. So this cannot. So this cannot be not. So this cannot be possible. So we need to look for these. So if we look for it here, okay. So now we need to find what all indexes can we pick. So we need to. So one point to note is that we are sorting the indexes by their occurrence. We store indexes in ascending order. This is important because then our condition of this quite literally becomes so this becomes simply j minus I plus k minus j plus uh, k minus I because we are picking indexes, we are picking any three index I, j, k. So they are guaranteed to be in this particular order. So let's say if I pick any three indexes, I pick this as I, this as j, and this as k. So they will always be in order. So we can reduce our condition this to simply this. So our sum will simply become 2k minus 2I, which becomes 2 times of k minus I. So we see that we don't need the middle index at all. So this is small optimization we can look for, but here we are not considering. So now we need to pick three indexes. How should we pick the index? Let's say I pick this index as I. Let's say I pick this index as I. This index has j. Now I have option to pick k from all of these index. I can choose this as k, this as k, this as k, and this as k. So if you look, if I pick this as k, our sum will become 1 minus 0. So if you see, if I pick this, k, I, and j sum will remain same, but k will contribute k minus j plus k minus I. If I pick this as k, it will contribute k minus j plus k minus I, and so on. So if I pick this as k, it will contribute 5 minus 1 plus it will contribute 5 minus 0. So if we are sure that we have picked these two elements, then we need to simply, this will contribute 1 minus 0 to the sum. And when we add a k, it will contribute k minus j and k minus I. So when k is 5, this will be our sum. And now let's say this is our k. So in that case, it will contribute this and this. So in that case, it will become 9 minus 1 plus 9 minus 0 and so on. If we pick this as k, it will become 11 minus 1 plus 11 minus 0, 11 minus 1 plus 11 minus 0. And if we pick k as 12, it will become 12 minus 1 plus 12 minus 0. So we see that out of these four, if you say, this sum will be the smallest because this will come out to be 4 plus 5, it will come out to be 9, it will come out to be 17, it will come out to be 21, and it will come out to be 23. Yeah, so this will be the smallest. And we saw that when we took k closest to j, in that case we got the smallest sum, right? Because we have this list sorted. Because if we have 5, then we are sure that if we took any k greater than 5, the sum will always increase. It will never decrease. So this sum always increases. The sum will always increase. This is because we have the indexes sorted in ascending order. So it's beneficial if we have picked I and j, we have selected, the next k index should always be just after I. So case 3, if we have decided I and j as indexes, then k should always be then k should always be j plus 1, always next. Okay, so yeah, but let's say this is for, so if we pick this as I and this as j, this will be our k. Now let's say I don't pick, now I need to select how, if we have selected I and j, then k will always be the next element. But let's say I have just selected I have not selected j. So j can be this. So we can have I, j and k. If we have selected this as j, then it will be j and k. So if you will again look, since the elements are ordered in increasing order, this sum will always be less than this sum because we are doing this. Because if you look in the first case, it will be 10 minus 3 plus 13 minus 3 plus 13 minus 10. In second case, it will be 13 minus 3 plus 14 minus 3 plus 14 minus 13. So if you look, this sum will always be less because elements are closer here. If we select farther elements, it will always be higher sum. So, so if we have I decided, then j should be I plus 1 and k should be j plus 1. So, so all our three indexes should be together. So we got to know that for the smallest sum because they're ordered as indexes are ordered in increasing order. But now there is a catch that if we have selected these elements, now what should be the position of I? So now I can start, so I index, so ijk can be this. So if we look at this example, what are the possible combinations of ijk? So ijk will be 0, 1, 5, or if we start I from this position, it can be 1, 5, 9. If we start from this position, it will be 9, it will be 5, 9, 11. If we start I from this position, it will be 9, 11, and 12. So these are different possible values of I. I can take this. So I can take these four values and then. So we'll simply calculate the distance of these three and then take the minimum. So if we don't know if we have selected I, then J and K will be just after that. But we don't know the position of I from where to select. So we need to consider all possible places of I because it can be possible that the later indexes are all together. because of which the value will become minimum. So that is. So this is the whole problem. So what we have done is that we have taken the sum as nums, and we have taken, since we need to find the minimum possible distance, I have taken the maximum answer as int max. So we have saw for the first case that if n number of elements is less than or equal to 2, we simply return minus 1. Then what we are going to do in this approach is that we will maintain a vector, since we know that nums of I have each element will be less than or equal to the array size. So we will maintain a vector. So we will maintain a vector which will store, which will just store what we are trying to do here. So we maintain a vector of size n plus 1 because nums of I can be less than or equal to n, hence l plus 1. Then we iterate over the whole array. We simply insert the particular index inside the vector whose number is present. So like when we come here at 1, we insert the index 0 under the vector 1. So under the vector 1, we insert 0. So in this way, for each element, we'll keep on storing its indexes. But we'll only store 3 indexes because we need only 3 indexes. So for each element, we'll keep on storing 3 indexes. So like, so if we see here, so yeah, so we came to 1, we inserted 0. Then we came to 1 here, then we inserted again index 1. Then we came to number 2, we inserted the index 2. Then we came to 3, we inserted the index 3. Then we came to number 2, it is at position 4. So under 2, we place index 4. Then we came to 1, we inserted 5. So now we see we only maintain 3 elements for each. So we simply did this. We saw that if for any number it has 3 indexes present, what we'll simply do, we'll extract we'll extract all the 3 elements of the vector that are currently present. So this will become first, this will become second, this will become third. We did that here. We popped it, we fetched the last element and popped it. So in this case, our A will become 0, B will become 1, C will become 5, and the whole array will become empty for 1. We'll simply calculate the distance, which is absolute of these 3 values, which was the distance that was given to us. We can ignore absolute also because we know A, B, C are in sorted order. So we'll calculate the answer and then we'll simply insert the second and third value. Because 0, 1, 5, now the next index that will come, we need to compare it with these two. Hence, we removed all the 3 and then we inserted 1 and 5. So that when 1 comes next time, it can be compared with its previous 2, just the previous 2. So in that case, we removed the first element at all and kept the second and third, so that the new element can compare it with the last 2 elements that occurred, because we need 3 consecutive elements. So we inserted them back, and then in the end, if our answer is still maximum, we didn't found the minimum answer, we simply return minus 1, else we return the answer. So if we look at the time complexity, we simply iterated over the array once. So it will be O of n, and space complexity. In the worst case, if each element occurs once, it will be simply O of n into 3 times. It will be still O of n only. Yeah, yeah. This was all for this question. Hope you liked it. Thank you.